So this is, it looks like one piece of metal, but it's actually two different pieces of metal. So when you heat up metal, do you think metal expands or contracts?
Metal generally expands.
Why?
Science.
Science. Okay. Well, again, if you model this as second graders out on the playground, okay? So imagine this is second graders like it is 30 degrees outside. It's really cold. They're just going to huddle together. You take them out the next day and it's like 80 degrees. What are the second graders going to do?
Just go more.
Yeah, they're going to occupy more space because they have more kinetic energy. So I'm going to heat this up and the metal is going to expand. But there's actually two different types of metal here, so it's going to expand at a different rate. So when I heat that up, you notice that it curls, okay? The reason that it curls is because the metal on the outside of this is expanding more than the inside is. Now, and you'll see this mathematically later on, this is based upon a change in temperature. This is not based upon temperature. Expansion and contraction occurs with a change in temperature. So when I heat this back up, okay, you reestablish that bigger change in temperature. Right now, everything's going to cool back down. So if you have the old style thermostat in your house where there's like a little slider that you move to set the temperature, basically what happens is that inside your thermostat is that there's a piece of metal like this. So as the temperature in your house changes, the pitch of that piece of metal changes. And so when you set it to a particular temperature, like in the wintertime, so if it gets too cold, what happens is if it gets too cold, this piece of metal comes up and it comes in contact with that slider. That connects or completes the circuit. It sends a signal to the furnace that says, hey, we need to kick on. Then, when the temperature of the house warms up, that cools back down, it loses contact with that point, and then it shuts that off. Same thing is true on the air conditioning side. So, the point being is that not all metals or all materials have the same expansion rate, but they all expand when you create a temperature change. And the bigger the temperature change is, the more that expansion occurs. Now, so I've got this, which is specifically designed for this. So this is brass, and that's brass, it's the same material. And if I put that in there, that just barely fits. Like there is like no tolerance whatsoever, okay? It fits, but barely, okay? So now I'm gonna heat this one up. So, Sydney, what should happen once I heat that up and try and put it back into the ring?
It's not going to fit.
Why not?
The brass molecules are heated up so they're moving faster, so it expands.
Okay? It's like giving second graders Skittles. They get excited. And they we like Skittles. And so now when I try and do this, I can't get that to fit in there. Okay, like I cannot get that to go through because this expanded so much and there was such a tight tolerance that that won't go through. But if I take that, cool it down, take away Skittles, then it goes back through again. So that's if I heat up this side. Next one, I'm going to heat up the ring. Okay? So there's three things that can happen to the ring. There's going to be no change in the size of it at all, and it will fit the exact same way. Or the ring is going to expand, or the ring is going to expand, but it's going to expand inward and make the ring smaller. Okay? So either it stays the same, it gets bigger, or it gets smaller. Chuck, thoughts?
I didn't think about it like that.
Okay?
Those are my thoughts.
Okay? Abigail.
I think Charles.
Bigger,
Why?
more Skittles.
Okay? You have more Skittles and it's going to expand outward. Connor S?
I feel like something happens. I'll go 3. I'll go option 3. I'll be bold.
So it'll expand outward and it'll expand inward, so on balance, it's just gonna stay the same.
I think outward.
You think outward. Anybody on the inward train?
I'm gonna disagree with Charles, just because. Is that my train?
I don't know.
Yes,
You're on the
that's
inward
your
train.
Is that 3?
I think all the sides of the ring are gonna expand, so it's not gonna fit in.
Yeah.
So you
It's gonna
think
go
it's
both
gonna
ways.
expand in every dimension, including getting smaller, so the ball wouldn't fit?
Correct.
I agree with Aiden.
You're in?
I agree with Aiden.
Yeah.
Which is what?
It expands equally in all directions, but that'll make it bigger. The hole will stay the same size. 'Cause it's expanding.
But if it expands inward,
But it's expanding outward at the same time.
It shouldn't.
Was that not
He's
the option?
kidding.
I
I don't think
choose.
it's-
We'll think expand. I choose
okay,
the right
let's narrow it down to this.
Because I
It gets
Okay, let's get, here's your options, let's narrow it down to this. Okay, so right now, it fits with no tolerance. So option 1, nothing changes, it fits just the same as it did. Option number 2, this gets smaller and it won't fit at all. Or option number 3, it expands and it fits easier. Okay? So how many say it's just gonna stay the same and it won't make any difference at all? What, Chuck?
That's the one that's gonna be right now.
Oh, why?
I wanna be different.
Okay, how many think that it's going to expand inward and it won't fit as easily or at all? Like I might not be able to get that in there. Okay? About half the class. How many say it's just going to expand outward and it's actually going to be easier to fit in?
But the way he said it,
2?
the off chance that it's
What?
A.
I didn't say it anyway.
On the off chance that it's A, I feel like it's gonna be 1.
I think it's A.
Okay, so let's heat it up.
If it's A, I'm crazy, and if it's not,
I think it's A.
I was just.
And A is what?
It's
no
gonna
change.
Still fit, no change.
No change.
Yeah, that's what I thought. Quit hitting, switch back to you.
Okay? So we'll heat it up nicely.
That doesn't change the mass, though.
Actually got bigger.
Yeah,
'cause
Oh, yeah.
that goes much
I
simpler.
originally thought that.
Okay? So it actually got bigger. Now, which is somewhat counterintuitive, because most people go, it should expand and it should get smaller.
Oh, but they want.
But Mother Nature is a lazy prima. So think about it this way. What if here's the easiest way to think this through. Imagine that this had been a solid sheet of brass. And I had cut that out, but then I put that piece back in there. Okay? So that piece that I had cut out, I reinsert in there. If I heat that up with that piece of metal in there, that's all going to expand out from the middle, and it would expand outwards. Okay? So what's happening, because if you've ever tried to make something smaller, that's tough to do. Because you've got, like, if it did get smaller, then you'd have to squeeze those particles closer and closer and closer together. That's a lot of work for Mother Nature to do, and Mother Nature goes, hey, sorry, you're not worth the effort, okay? So that's why when I heat this up, that it gets bigger. So in a lot of times, like on especially like heavy equipment, they take advantage of this. So they'll have like a bearing or something that they want to fit over an axle. So what they'll do is, like if this is the bearing, they'll actually take this, or the shaft, and they'll put this in liquid nitrogen. So they'll get this really, 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 really cold. But the piece that they have to fit over it, they'll heat that up. So this gets really, really cold and shrinks. This gets really, really hot and expands, and then they slide it over it. But then, when it returns to normal temperature, this is going to expand. This, as that gets bigger, right? This is going to shrink, and then it's like a heat lock. So it locks that bearing on because you have both systems, one expanding, the other one getting smaller, and then it's locked on using heat or lack thereof. Okay, we're cool. Back we go.